Page 339, we're going to go through the answers for lesson 6-4 in case there were any of these you had questions on. So number 6, they did a study of fuel efficiency of cars, and the information's over there to the right as well as in the paragraph here. And they are asking about the means. These are the means that they're telling us. So you can see 23 miles per gallon versus 44. So for group 1 is less than the mean for group 2. And so what that means, we could say, is that the cars in group 2 generally are more fuel efficient. What that means, fuel efficient, it means they get better gas mileage. So if you didn't know what fuel efficient means, now you know, and that would be something you could just do a quick search on the internet if you're not sure what the word means, or a dictionary maybe could be able to find it also. And so the last statement, the cars in group blank may be smaller. Okay, maybe emphasis on the word may here, but cars in group 2 may be smaller. And kind of the idea with that is if the cars are smaller, then they're going to be lighter. They don't need as much material, as much steel and whatever they're using to make these vehicles. And so it's going to be lighter, and then gravity's not going to be pushing down on it as much, and it might be able to get better gas mileage. Again, that's just a generalization, but a lot of times the most fuel efficient vehicles tend to be smaller than ones that are not as fuel efficient. Number 7, they have dot plots with random samples of vertical leap heights of basketball players. Compare the mean values and round to the nearest tenth. So Camp 1, they already told you what to do here, but basically you would have to add all these numbers together. 22 plus 23 plus 25 plus 25, 27, 27, 27, 28, 32, 33, 34. You have to add all those together, which ends up being 303. And then if you divide that by 11, you get 27.5454, and so on. The directions here said that we are going to round to the nearest tenth. So the 10th place is right after the decimal point. So it's either going to be 27.5 or 27.6, closer to 27 5/10, 27.5. So if you do the same thing for number 2, if you add all those together, 18 plus 21 plus 22 plus 22 plus 22 and so on, that should come out to 268. If you divide that by 11, you get 24.3636 and so on. And so nearest tenth, that would be 24 4/10. And then the question at the end, mean values tell you that participants in camp blank jump higher in general. So 27.5 inches versus 24.4 inches. Camp 1 generally jumps higher. Okay, again, that's not to say everybody jumps higher, but if we look at the mean, that's what it is. And you could argue on that one. I mean, you might say, well, we've got some outliers here, so it would be better for us to use the median. Might be the case. That's not what they were having us do, so we can't really argue against the methods of what they're wanting us to do there. So number 8, we have marbles in 2 sets. So data set 1, the mean is 13.6 grams. And data set 2, the mean is 14 grams. and the MAD, or mean absolute deviation, of both sets is 2. So what can you infer about the two sets of marbles? So a couple quick statements we could say. We could say that the mass of set 2 is slightly higher than set 1. We could also say that both sets have the same variability. Since the mean absolute deviation is the same, the deviation from that mean is equal for both sets of marbles. Number 9, Brianna asks 8 classmates how many pencils and erasers they carry. Mean number of pencils is 11, and the mean number of erasers is 4. Mean absolute deviation of both is 2. What inference could Brianna make? So, kind of a statement of the obvious here maybe, but we could say most of Brianna's classmates carry more pencils than erasers in their bags. Okay, a mean of 11 versus a mean of 4. Obviously a lot more pencils they're carrying than erasers. Number 10, 2 machines in a factory are supposed to work at the same speed to pass inspection. Number of items built by each machine, 5 different days recorded. Inspector believes the machines should not pass inspection because the mean speed of machine X is much faster than the mean speed of machine Y. So which measures of center and variability should be used to compare the performances of each machine? So look at the numbers here. Here's our issue. That is a major outlier. Okay, so maybe the machine broke down that day and they had to fix it, so it wasn't running as long. It didn't build as many items. That's a major outlier. So for this, probably would be best if we use the median and IQR, since there's an outlier. That's going to have a big effect on the mean and the range. And then, so part B, is the inspector correct? So we could say something like, no, the median speeds are the same for both machines, so they should pass inspection. Going back to the problem again, it said that the machines are supposed to work at the same speed in order to pass inspection. So we just had an outlier. There was one day where the one machine was kind of out of whack there, but overall, if you worked it out, the median would have been 21 for both machines. And so, or actually, sorry, it would have been 19, median of 19 for both machines. So they should both be fine. They should pass inspection, I would say. Number 11, we have dot plots showing how the weights of a random sample of fish from 2 lakes. So which comparative inference about the fish in the 2 lakes is most likely correct? So the first one says there is about the same variation in the weights between small and large fish. Variation, we're kind of looking at the range or mean absolute deviation we could get into. You can see on South Lake they're a lot more spread out, they're a lot more varied, so I would not choose that one. B says there's less variation in South Lake than in Round Lake. Nope, it's the opposite way. C, there's less variation between small and large fish in Round Lake than in South Lake. That's the one we want. And then just to double check, D, there's greater variability in Round Lake. No, there's actually less variability in Round Lake. So C would be our definite answer for that problem. So this gives you an idea of what we're looking at in lesson 6.4. I'm going to try to keep putting a joke on every day with the assignment. If you guys like that or have a feeling one way or another about jokes, then you can send me an email, and then I'll know if you watch this video. Hopefully everybody's watching this and understanding what we're doing. And again, just make sure you ask me questions if any of this is still not making sense. Have a good day.